Hi everybody, we're going to talk about things called square roots and real numbers today. So I mentioned real numbers the other day. We're going to find out what it means to be a real number, what's not a real number. If you would like to, you can watch this video. If not, if you would rather read along in your book, this is chapter 1, section 5, and we're going to run through that today about classifying real numbers. And where that takes us is it allows us to say things like we introduced, this idea was so important, we introduced a new symbol, and it looks like this. It's called the square root symbol or the radical. That symbol is called a radical. And we say things like the square root of 25 is 5. And it's 5 because 5 times 5 is 25. Or I could say the square root of 81 I know is 9 because 9 times 9 gives me 81. So the square root of a number is that number that when multiplied by itself gives you the number you are looking for, okay? What we want to look at today is estimating square roots that are not perfect squares. So what are we going to do if we're asked a question like, what's the square root of a number like 72? What's the square root of 72? Well, we can do that. We can get really close to what that square root is. We can't tell it exactly, but we can get a pretty good estimate. So we want to estimate how big is the square root of 72. Well, I'm going to use my multiplication chart to figure that out. And I want to think of those numbers on the multiplication chart as a continuum. So I have 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and so on. 72 would lie between 64 and 81. So if I think of the number line, and let's say this is 64 and this is 81, and I want to put 72 in there somewhere. Well, let's see, 72 is almost halfway between 64 and 81. It's, let's see, 8 units this way, and it's 9 units this way. So it's a little bit closer to 64 than it is to 81, which means that the square root of 72 is going to be kind of right between the square root of 64 and the square root of 81. Well, the square root of 64 we know is 8, and the square root of 81 we know is 9. That means we can get a really good estimate for the square root of 72. It should be right about halfway between. And in fact, if I asked, I'm going to estimate 8.4 or 8.5. And if I ask Siri or I ask Alexa, because I just did that, Siri or Alexa would tell me the square root of 72 is about 8.48. So I want you guys to make an estimate within, to the nearest tenth. If you told me 8.4, that's fine. If you told me 8.5, that's fine. You don't want to go lower than 8.4. That's kind of aiming closer to 64. More than 8.5 means you're closer to 81, and it really is a little bit less than halfway. So let's try this with another number. Let's estimate the square root of 18 to the nearest tenth. Okay, so on the continuum of the number line on this multiplication chart, and I think about where 18 would lie, 18 would be between 16 and 25. So here's a number line. Here's 16, and we know the square root of 16 is 4. And here's 25, and we know the square root of 25 is 5. 525, that's my birthday. So we want to think about where 18 is. Well, 18 is a lot closer to 16 than it is to 25. So here's 18, and if I take the square root of 18, I should be pretty close to 4. So between 4 and 5, a lot closer to 4. I'm going to make a guess of 4.2. Now I'm going to ask Siri. And I asked Siri, and Siri told me the square root of 18 is about 4.28, 4.24, I think. So I got pretty close. I did a really nice job of calculating that square root by just estimating it. So let's do a couple more. Okay, I'm going to think about the square root of 37. And again, I need to think about the perfect squares that are around 37. Well, just below 37, we have 36. That's a perfect square. Its square root is 6. And after that, if I think about 7, 7 squared is 49. So 49 is the next perfect square. So 37 on this continuum is right after 36. It's really close to 36. The square root of 37 should be really close to 6. I'm going to estimate it at about 6.1. And if I check my calculator, that's not a bad job. Square root of 115, well, let's see, I'm getting some bigger numbers here. Right below 115, let's see, I have 100 is the perfect square. And above 115, I have 121 as a perfect square. Square root of 100 is 10, and the square root of 121 is 11. So 115, square root of 115 should lie between 10 and 11. So I'm going to ask myself, is it closer to 110 or is it closer to 121? And it's closer to 121, probably around here somewhere, square root of 115. So my answer should be more than 10.5. Maybe 10.6, maybe 10.7, maybe 10.8, somewhere in there. I'm going to guess 10.7. And when I asked Alexa or asked Siri, I was pretty close. It's about 10.72. So notice I'm not going on with numbers after the 10th place, but I should be able to place on the number line or figure out about how big those numbers are. Estimating those square roots helps us get a good idea of how big numbers are and where they are in relation to other numbers. Square root of 3, let's see, square root of 3 lies between two perfect squares. It lies between 1 and 4. Square root of 1 is 1, and the square root of 4 is 2. So 3 lies kind of right here. The square root of 3 should be a little less than 2, but there's not much room there, right? It's not divided up by that much. So if 2 was here and 3 was here, maybe about, it's not 1.5, maybe about 1.6 or 1.7. And this is one I know off the top of my head is about 1.7. Okay, so we should be able to estimate square roots. Why don't you hit pause, try these three, try to estimate them, see how close you come. And again, if you're around the 10th place, that's fine. If you're off by a lot, I'm a little worried. But if you are off by a 10th from my answer, you're in good shape. Okay, so hit pause, try those three, figure them out, and then I'll give you the answer. Square root of 14 is about 3.7. How'd you do? Square root of 78 is about 8.8. And the square root of 40 is about 6.3. So if you said 3.8 or 3.6 for this one, that's okay. 3.9 is a little too big. 3.5 is a little too small. It's closer to, 14 is closer to 16 than it is to 9. So we should be more than halfway there. Okay, so we just place them based on kind of where they are in relation to the other perfect squares. So we've talked about this, the square root of 16. 16 is a perfect square. Its square root is 4. Square root of 17 is a little more than 4, right? If I use my calculator, if I plug that number into my calculator, I get, my calculator tells me, hold on a second, I keep putting the wrong number in, 4.123105625617661. And the only reason it stopped there is because my calculator ran out of digits. It ran out of space across the screen. So one of the things we want to talk about when we talk about numbers is rational versus irrational numbers. When we talked the other day, we had the fraction 9/22. and that turned out to be 0.4090909 with the 09 repeating. That's what's called a rational number. Any number that can be written as a ratio, the ratio of two numbers, or written as a fraction. Any number that repeats or that ends is called a rational number. But then we start to get these weird numbers. We call them irrational numbers. Numbers like the square root of 17. A lot of oddball square roots, square root of 3, square root of 5, square root of 6, square root of 7. If it's not a perfect square, it's almost always an irrational number. This number is never going to repeat itself, and it's never going to end. That's an irrational number. Our most irrational number that you all know of is pi. Pi, we say, is 3.14, but it's not really 3.14. It's, I don't know pi to very many digits. My calculator tells me 3.141592653589793, and then it keeps going and going and going. None of the digits ever repeat in a pattern. So here we've got, you might have two digits next to each other that are the same, but there's no pattern that's ever going to repeat. And that's called an irrational number. It means it cannot ever be expressed as a fraction. Irrational, I keep writing ration. Can never be expressed as a fraction. Sometimes we approximate it to be 3.14. It's about that much, but it's not exactly that much. This is good enough for a lot of our calculations, but that's not the exact value of pi. Okay, so for today's lesson, I think we'll talk about the other number sets tomorrow. For today's lesson, you should be able to estimate square roots and then know the difference between a rational number and an irrational number. And we'll talk more about those tomorrow when we talk about the real number sets.